say for a ratio test, things that you should keep an eye out for are this. Anytime you see a factorial, you think ratio test. If you see a number to the n, and it's not just by itself, it's mixed with other stuff, then think ratio test, okay?
Okay.
So what is the ratio test itself? So ratio test is going to be the limit as n approaches infinity of a sub n plus 1, okay? So what you do is you create another series, the next term in the series, by plugging in an n plus 1 everywhere you see an n.
Mm-hmm.
Okay? And again, here, we're going to compare it to 1. And if this answer, we'll call this answer L. And the conditions are if L is less than 1, it converges. If it's greater than 1, it diverges. And if it's equal to 1, it's inconclusive, and you have to do a different test. You understand?
Yeah.
So let's look at 3 to the n over, let's see, let's do this properly. N plus 1 factorial. Okay? So this should be screaming ratio test. Why? Because I have a number to the n. And I also have a factorial. So that should be all over it saying, do the ratio test. Okay? So now that you figured that out, what you got to do is you got to figure out what a sub n plus 1 is. So a sub n plus 1 is going to be plugging in an n plus 1 everywhere you see an n. You understand how I did that?
Yeah.
Okay. So if I simplify that a little bit, it's going to be okay.
Mm-hmm.
We got to take the limit of that over the next term, or the original term. Let's switch to white. And we put an absolute value that accounts for any alternating parts, okay? So don't think just because you see a -1 to the end, it's going to be an alternating series anymore, okay? If you see a factorial, if you see a number to the end, go to ratio test. I'll show you one here in a second that will have an alternating portion to it. So now what's going to happen is you're going to divide by the fraction. I would recommend to you to go ahead and get in the habit of doing these. If you practice enough, you'll see that the next step will be to multiply by the reciprocal. So instead of to save time, you'll probably go ahead and multiply by the reciprocal. But just to show you the problem for the first time, I don't want you to panic and be like, what just happened?
Magic.
I think you'd be okay. I think you could handle it. You're a smart young lady.
Thank you.
And then at this point, you simplify a little bit. You could plug in, I guess, but that's going to be infinity over infinity over infinity over infinity. That's a lot of indeterminate forms. So what I'm going to tell you to do is simplify a little bit before we do that. So if we have that, then we multiply by the reciprocal. Okay? So then let's clean house a little bit. All right, because at this point, if I plug in, it's still going to be infinity times infinity, which is infinity over infinity, right?
Yeah.
So that's still indeterminate. So let's clean house. Do you see any algebra we can do?
You can take the 3 to the n.
Okay, good. So this was 3 to the n times 3 before we used our exponents. So that can cancel with that. Anything else?
That n plus 2 factorial can be n plus 2 times n plus 1 factorial.
Very good. You start with the larger of the two, and you work your way down till you get to the next one, and you're like, oops, that is the same thing as that, so they can cancel. So we're left with, in the next office, okay, what do I do next?
Well, the limit, so n will go to infinity, so that would be a number over infinity, so it'll be 0.
Okay, so it would be 3 over infinity, which equals 0. What can I then say? All right, so at this point, that's going to be less than 1, therefore, absolutely converges.
So when we do the ratio test or the root test, we can say that it absolutely converges.
Correct.
We don't have to do another test?
No.
Okay.
You got it?
Yeah.
All right. Do you have any questions over this problem?
No.
Okay.